Okay, friends, let's start with that Census Bureau reference where they talked about the average American is actually female. So I did some quick checking to see where that data came from in 2018, and here's what I came up with. In the Census Bureau data, according to the Census Bureau, there were 166,049,288 female Americans and 161,118,151 male Americans. Now, the Census Bureau's job is to literally count every single person. So we're going to assume they did that. And the total, if you add these two together, you get 327,167,439 Americans in 2018, which is actually really close to, I usually use something like, 330 million as an estimate. So that's pretty darn close to what America would have been in 2018. So where did the 50.8 come from? But what they took was, they took a part over the whole. They took the part that was identified as female and divided it by the total, and that is where their 50.8% came from. Now, if you're wondering why there's no margin of error on that, because we've been talking about that quite a bit in 98, 105, and even a little bit in the beginning of this course, it's because this doesn't need a margin of error, because that's not a statistic. If you counted every single American, and this many of them are labeled female, then 50.8% are female. There's no plus or minus. There's no uncertainty. There's no need to talk about error. So that 50.8%, which was taken by part over whole, is actually defined well in statistics. Let's take a look at it.
Okay, so the population proportion, in other words, the percentage of the occurrence of something in the population, is often called little p. In statistics, we're going to have letters that stand for things quite a bit. And this is our first. And it's actually one of the nicest ones because you already know the formula. You've seen this formula before. Little p is equal to x over n. Now, we already mentioned that it's part over whole. Proportion, percentage, they all mean the same thing. So when you're talking about the little p, the population proportion, you're talking about whatever in the population you're studying, the proportion, the percentage, the probability, the prevalence. There's so many words that start with P that can stand for the population proportion. So you're studying something in the population and you want to know how prevalent it is. So therefore, it's the proportion in the population you're studying. How do you calculate it? Well, the first thing you do is you count up how many times the thing you're studying occurs in the population. And then you divide it by the size of the population. And that ends up giving you a nice percentage or population proportion. So for the population proportion of US females in 2018, we're studying the proportion of females. We're going to need to know the total number of females and the total number in the population. That's what we've got from our data. And if you divide 166 million by 327 million, you get your 50.8%. Like I said, you've already seen this. We've called it percentages, prevalences, proportions. It has lots of names that all mean the same thing. But in statistics, they tend to use certain letters to stand for certain things. So when you see lowercase p's, that means you're studying the population proportion. Here's a lighthearted example. If you've ever seen the movie Groundhog's Day, you might be familiar with Punxsutawney Phil, the famous Pennsylvanian groundhog that allegedly can predict whether or not winter is going to be exceptionally brutal. I'm not exactly sure how these guys in the top hats can tell whether or not this little creature sees his shadow, but here's the data they've collected since 1887. If we take out the data of no record, no appearance, or other anomalies, we could actually calculate the population proportion of the time he sees his shadow. Okay, so what's the proportion of the time we get in early spring based on Phil's data? Okay, well, I went and looked at it, and I saw 124 total years that were marked that we actually had data for. And in 20 of those, there was an early spring prediction. That comes out to 16%. So what's the chance of more winter? Well, it's got to be whatever's left, right? I mean, if 16% of them were in early spring, that means the other 84 are more winter. Punxsutawney Phil either doesn't see a shadow, which is early spring, or he does, which is more winter. And again, I have no idea how a groundhog sees or doesn't see a shadow. Apparently, it involves top hats, whiskey, and being in Western Pennsylvania. All right, so now we've looked at two examples of a population proportion, which quite simply is just the percent of time something happens in the population, something that you're interested in. Okay. But the problem with this is, how often can you actually examine the entire population? I was careful to pick two examples, the Census Bureau and Punxsutawney Phil's data, where the population data is known. But that's literally because a census, by definition, is counting everyone. And Punxsutawney Phil's inner circle of top-hatted people have kept track of his stuff for the past 100 or so years. Most of the time, you don't get to have the entire population to be able to be counted or measured or whatever. So most of the time, you have what's called a sample proportion, which is the proportion that something happens in an observed sample taken from an entire population. Now, the symbol for sample proportion is related to the symbol for the population proportion. You're going to notice this in statistics. Very often, the population measure that you're checking has one name, and the sample version of that has a related but slightly different name. So the sample proportion is called P hat, P with that little tiny hat on top of it. And I remember a couple years ago, I had some nurses in 243, and I called it P hat, and they chuckled because they have a very, very different idea of something called a P hat. And a couple years after that, I had a 244 class that actually liked the phrase P hat so much, they made me one. But anyway, the point being is that P hat in mathematics is absolutely no different than the population proportion. You simply take the whatever you're studying, count how many instances of that are in your sample, and then divide it by the size of the sample. Mathematically, there is no difference between a population proportion and a sample proportion. Let's move on to other kinds of averages next.